Hello everyone, this is Dr. Karen's, and today I'm going to talk about how to determine the field of view on a light microscope. Before we get started, I just want to say that this short lecture is specifically meant for biology for non-science majors at Eastfield, and even more specifically for the section that is taking this class completely online and using a lab kit. So what you're seeing on the screen right now is the virtual microscope program that we're using as part of this lab kit. So what is field of view and why is it even important? So field of view is the circle that you're seeing when you look through the microscope. So if you imagine that you're looking through this light microscope, when you look through the eyepieces, you see a circle. That is the field of view. Imagine if you put a slide on this microscope, you would not see the entire slide. You're only seeing what the microscope is able to see, and that is the field of view. So that field of view will change as your magnifications change, because every time you increase your magnification, the lens or the objective is getting closer to the slide. So you are able to see less and less of that slide the higher the magnification you get. And so the field of view will be smaller as your magnification increases. And so we're going to learn in a few minutes, how do we measure that field of view? Why do we even want to know this? Because there are many times when you're using a microscope that you want to know or have a rough estimate of how big the cells are that you're looking at. And you can't measure them because they're microscopic. But what you can do is compare them to the size of the field of view and then estimate roughly the size of one cell. So first of all, let's talk about how do you find this field of view? How do you determine it? So if you were using a regular light microscope, an actual light microscope in the lab, you basically just put a ruler on the microscope, on the stage, a ruler that has hash marks, a metric ruler, and you look through the eyepiece and you physically measure the diameter of that circle or of that field of view. And you can do this for the scanning lens, which is the 4X lens. You can do this for the low power lens, which is the 10X lens. And you also want to know the field of view for the high power lens. However, by the time you reach that magnification, that lens is so close to the slide that you can't use the ruler anymore, because the hash marks on a typical metric ruler, which are a millimeter apart, are too far apart at that magnification. So the field of view at the high power lens is usually less than a millimeter. So that's giving you some idea of how big the things are that you're actually looking at under the microscope. So we're going to be able to measure the field of view on this virtual microscope as well, with the 4X lens and with the 10X lens. So how do you figure out the field of view for the high power lens if you can't measure it? There's a calculation, and I'll show you how to do that in a second. So when you're in this virtual microscope, so again, this is through the hands-on lab science cloud that comes with the lab kit for this class. When I've opened up the virtual microscope, I've already moved my stage down, I've already turned on the light, I've already have my 4X or my scanning lens. Notice that it says low power here. That is not really correct terminology. It should be called the scanning lens. I have that 4X lens in place, and now I'm going to find a slide to put under this microscope. So I said earlier, if you had a real microscope, you would use a ruler and measure the diameter of this field of view. We're going to do the same thing here, but instead of using a real ruler, the slide library comes with a ruler. So it is under this field of view slide. So I'm picking field of view, And I'm going to use my coarse adjustment and start getting it into focus. You can use your mouse initially, but you actually might go too far. And so then I use my up-down buttons on my computer to start getting it into focus. Then I'm going to use my fine adjustment to get it into better focus. There we go. Now you want to, excuse me, you want to measure the diameter. So you have to position the slide so it is as close to across that diameter as you can kind of tell with your naked eye. And I like to line it up so one of those larger hash marks is all the way up to the left edge of the field of view. And so those are your, oh, and I see, well, I gotta go, I have lost some at the right. So let me fix this. Let me go back. Let me do this. Okay. So if this were a real ruler, these hash marks, the little hash marks would be 1 millimeter apart, but that is not true for this microscope. This slide is different from a typical metric ruler. And I'm going to go back. I'm going to pull up a different window and show you. This is the V-Scope lab as part of our lab kit. So this is lab 4. There is a page here in the exploration section that says rules for the V-Scope. And it says down here, the field of view slide. For that slide, that's that ruler slide that we're looking at, each mark on that ruler is 0.01 millimeters. So let's go back to the microscope. So each little hash mark on here is 0.01 millimeters. And so, again, I'm under the scanning lens or the 4X lens. And I just basically want to know is how long is this diameter of this area that I'm looking at. And so I'll count each little hash mark all the way to the end, and then you multiply that times 0.01 because each hash mark is 0.01 millimeters. Okay, so I'm not going to do that for you. I expect that you know how to count. So you're going to count these hash marks, multiply times 0.01, and that's your measurement for the field of view under the scanning lens. Now you also want to do the same thing under the 10x lens. So I'm going to change my magnification. I already have this in the best focus that I can get it in, so it's okay to move to the next magnification. I'm using the 10x lens. Let me get this into better magnification. I'm only going to use the fine adjustment because I have moved beyond the scanning lens. I'm going to reposition this a little bit too. So it's definitely in the center. And I always, this is a personal preference of mine, I like to line it up so one of those larger hash marks is all the way up to the left edge of the circle. Notice how we've magnified the ruler, right? And so we're going to see fewer hash marks because we are closer to the slide. So when you increase magnification, the field of view gets smaller. You're seeing less of the slide. You do the same thing. Count each hash mark, multiply it times 0.01. That's how many millimeters long this diameter is. And so those two measurements for each of those magnifications, you will put that in your lab report in the HOL cloud. All right, so that's how you can figure out the field of view for the scanning lens and for the low power lens. But how do you do it for the high power lens? So I said before, usually, in most cases, if we were to go to the next magnification, we wouldn't be able to use the ruler. Now, that's debatable here. You can go ahead and try it. You can advance to the next magnification. You might be able to count because this ruler is a little bit different from a typical metric ruler. But typically, you have to do a calculation to figure out the field of view at the high power lens. And we want to know what the field of view is at the high power lens as well, because most of the time in this class, you're going to be looking at bacteria or yeast. And those things are very, 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 very small, and you're going to need to look at them under the high powered lens in order to see anything significant. So I'm going to open another tab here. This is the microscope lab from our lab kit. So lab 5, microscopy for microbiology. This is, let me scroll up for a second. This is experiment, the first exercise in this experiment, getting to know your compound microscope. And I'm scrolling down here. This is where they want you to figure out the field of view for all 3 lenses. When they say low power here, they really mean scanning lens, because they're saying use the ruler here with the low power lens, then do it again for the medium power lens. We just did that. I just showed you how to do that. Now for the high power lens, you have to do a calculation. And you're going to do a calculation using the numbers you just figured out from the other lenses. So what is the equation? So you're trying to find the field of view for the high power lens. That is equal to the field of view for the lowest power lens, in this case the scanning lens, the 4x lens, times the total magnification of that scanning lens over the total magnification of the high power lens. What are those numbers? We know the field of view for the scanning lens. You just figured that out. I just showed you how to figure that out. That's the number you would use right here. Total magnification of the scanning lens and the high power lens you had to determine in an earlier part of this exercise. And remember, total magnification is the magnification of the scanning of the lens that you're using times the magnification of the eyepiece. So the scanning lens has its own magnification of 4x. The eyepiece in the virtual microscope has a magnification of 15x. How do I know this? Normally in a light microscope, it's 10x. It's not the case for the virtual microscope. How do I know that the eyepieces in the virtual microscope are 15x? Go back to the virtual scope lesson in the lab, and it tells you right here, the ocular lens of the V-scope is 15x. Okay, so going back to this calculation, the field of view for the high power lens is going to be equal to the field of view from the scanning lens, which you determined here at step 9 and 10, times total magnification of that scanning lens, which will be 4x times 15, divided by total magnification of the high power, which will be, the high power is 40x times 15. So plug those numbers in and you get the field of view for the high power. Now what would be interesting is if you used the ruler to measure and then did the calculation and see if those numbers agree. All right, so that's how you would determine field of view for all 3 of those lenses using this virtual microscope. There will be another video that I will post that will talk about how you use the fields of view to estimate cell size, so stay tuned for that.